So here we come to IGCSE Mathematics Paper 4, Specimen Paper 2020, to question 9, Part A first. So we have some triangles this term. So this term is about the Cosine Rule. So first of all, let's recall what's Cosine Rule. So for some SSS type triangle or SAS type triangle, we can use the Cosine Rule. For example, ABC here. So let's the opposite side for the angle A be A. This is small a, and then similarly this is small b, and then this is small c. So the rule is just similar to the Pythagoras theorem. C squared is equal to a squared plus b squared, right? Pythagoras theorem. And then remember, minus 2ab, alright, the two sides on the right hand side, alright, the AB, and then cosine, of course, cosine rule, cosine, and then the angle will be using the starting point, this one, the bigger one, but the angle C, like this. So C is blah blah blah. So for SSS and SAS, we can use this to solve the other unknown. Okay, then we need to think about AD. Where is AD? Where is from which triangle contain the AD thing? So obviously AD is here, right? So it must be ADB or ABD, right? ADB that contain the side AD. So we think about this triangle ABD. When we think about the triangle ABD, we have three things we know, right? Two sides and then one angle. And then this angle is in between these two sides. So this type of triangle is kind of SAS triangle. Okay, so for SAS triangle, we can use the cosine rule. So apply the cosine rule to this one, and then we can find the AD. Right? So according to the formula, it should be the AD square. Right? This one, AD square will be equals to the other side, two sides. So it is 70 square plus the 55 square, and then minus the 2 and then multiply the other two sides, 70 and then the 55, and then remember the cosine rule, cosine, and then the middle angle, okay, 40 degrees. That's the angle B, right? B, actually this is B square, you can think about this, right? But I will just use AD square here. So here you can just use the calculator to calculate the AD square is how much, and then take the square root. So after using the calculator, you blah 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 blah, and then take the square root of this one, you can get this number. Correct to a free significant figure, I will put a 45.0 here. So 45.0 meters. Alright, so we got the AD. So then we come to question B here. So this time we will use the sine rule. So before we think about the question, for the sine rule, it is most suitable for ASA and the AAS type of triangle. So two angles and one side, it will be the best, right? Because for two sides and one angle, normally you can use the SAS, so this you can use the cosine rule to finish this. But if it's like the SSA type of triangle, you can have two values of that. So normally you will see for ASA or AS two angles will be more suitable for us to use the sine rule. So for the sine rule, we got the formula is A over sine A, or the opposite side to the angle, to the side of the angle, will be equals to B over sine B, will be equal to C over sine C. So you got this. But there are 6 unknowns, right? So normally we will just focus on 2 of them. Alright, so maybe using this, A over sine A equals to B over sine B. So you pop 3 numbers into either 3 unknowns. Alright, so and then you will get the final unknown. Okay, so let's focus on this graph again. So we need to calculate the length of BC. Again, we need to think about which triangle it is in. So it must be BC something, right? So you just have BCD and only, right? The triangle BCD, so nothing else, right? So you think about the triangle BDC or BCD, you will find that you just got 2 numbers. Okay, so you need one more thing to solve it. no matter sine rule or cosine rule. So you may think about, is AD useful for this? But AD is here, so it seems not to be useful in this. But you think about, and then you think about the parallel lines. These two are parallel. So you got the 40 degrees, you can move it to here. Using the alternate angles, and BD, AB parallel to CD, right? Then you can have the 40 degrees in the triangle BCD. So you got two angles and then one side. So it's kind of a AAS type of triangle. So you can use sine rule now. So because of the sine rule, the BD is opposite to the 32 degrees, right? And then you need to think about the 40 degree is actually opposite to the BC. So you can just calculate the BC, alright? So for the BC will be opposite to sine 40 degrees. And then for the BD, that's the 70 meters, will be opposite to the sine 32 degrees. And then you can just calculate the BC by removing the sine 40 degrees to the right hand side. So actually it's just this, and then multiply it by sine 40 degrees, and then you just finish it off with your calculator, and you will get that BC should be something like this. Okay, 84.9 something, and then correct to the correct to which free second figure. Alright, so should be 84.9 meters. That's it. So part C is about how to calculate the area of a triangle. Okay, so recall the formula for the area of triangle, apart from the 1/2 and then multiplied by the height and then the base. Okay, we can also use this if it is kind of a SAS triangle, or the angle is in between these two sides. Then we can use this formula. The area of the triangle will be 1/2, or with the half of multiplied by A and B to two sides, and then the sine, remember it's a sine of the middle angle, like this. But before we do it, actually for this figure, you may think that it is a trapezium, so you can just find the DC, the upper side, and then plus the lower side, lower base, and then multiply by the height if you can find it. Actually, you can find it, and then divide by 2. You can do it that way, but it will be quite clumsy. So this time I will just separate into two triangles and calculate the triangle ABD first. So when you watch the triangle ABD, oh, this just two sides, SAS, alright, two sides and one angle, or kind of a SAS. So you can just calculate this area using this formula. And then for the triangle BCD, you already have this side, or 70 meter already. And then for the BC, you have calculated in part B, right? So it is yours. But you don't know this angle, because you need to have SAS if you want to use this formula, right? So you need to calculate this angle using the angle sum of triangle, because it is 40. We have already proved it in the part B, right? So you can use the angle sum of triangle, and you will get this should be 108, right? Yeah, 108 degrees. So here you can just use the formula now. So you can see here I will use 84.9 blah 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 blah. So to make sure the final answer is very accurate. Okay. So, and remember it's sine theta, so sine angle. So you just use your calculator to blah 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 blah, and then you will get the final answer. It will be something like this. Yep. And then correct to the 3 second figures, we will have this as the final answer. So this time for part D is asking about the definition of the trigonometric ratio. So you need to find the shortest distance from A to BD. So actually what you are finding is you draw a line from A and then perpendicular to BD, or something like this. Alright, let this be E. How about that? Let's this point be E. So you just want to find AE, how long is AE? So let's recall what is trigonometric ratio. The definition, let's theta be here on, and this is the 90 degrees. Okay, this is the 90 degree. Then this we call the opposite side, and then the longest one is the hypotenuse, of course, and the remaining thing is the adjacent side. So for the sine theta is the opposite side divided by hypotenuse, and then for cosine theta is the adjacent side divided by the hypotenuse. So hypotenuse must be in the denominator side for sine or cosine theta. And then for tangent theta, it will be the opposite side divided by the adjacent side. So another thing you can see, for opposite side, it must be in the numerator. It can't be at the denominator side. So, but you just need to memorize it, right? Opposite, blah, 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 blah. So here, let's think about the triangle ABE here, ABE. If you want to calculate the AE, this is the opposite side to the 40 degrees. And then we have the hypotenuse, and then we have the theta, of course. So this opposite side and then hypotenuse will make a sine theta. So you just use the sine 40 degrees, the theta is 40 degrees, will be equals to the AE divided by the hypotenuse 55. So you want to calculate AE, so I will remove the 55 to the left. So it will be 55 times the sine 40 degrees will be equals to the AE. And then you just use your calculator, you will get that AE should be something like this. Alright. So having the 3-second figure, you will have it 35.4 meter. That's it. The end.